Tencent Hunyuan unveils high ASR 3.0 preview, a new paradigm in speech recognition from hearing clearly to understanding deeply. August 5, 2026, 14:25 GMT+10. Add to Google preferred sources. On August 4, Tencent Hunyuan released its next-generation speech recognition model, high ASR 3.0 preview. Built on the High 3 large language model, it achieves a leap from merely hearing clearly to deeply understanding, intelligently correcting homophones and resolving ambiguity by leveraging context. Its word error rate on open-source evaluation sets is controlled at around 3%, and its dialect recognition covers 10 major dialect regions in China. Technically, it employs a mixture of experts' Mo architecture and is jointly trained on tens of millions of hours of data, significantly enhancing robustness in complex acoustic environments. The model's API is now available on Tencent Cloud, with the AI assistant Unveils completing its initial integration and offering the service for free to users. Key elements: Tencent Hunyuan unveils high ASR 3.0 preview, a new paradigm in speech recognition from hearing clearly to understanding deeply. Tencent Hunyuan has dropped a bombshell in the field of speech recognition. On August 4, the company officially released its next-generation speech recognition model, high ASR 3.0 preview. Unlike traditional transcription tools that solely pursue hearing clearly, this model's core breakthrough lies in integrating the language understanding capabilities of the latest generation large language model, High 3. This achieves a paradigm evolution in speech recognition from word-for-word transcription and single-point optimization to contextual understanding, scenario compatibility, and one-click output. Simply put, the goal of high ASR 3.0 preview is not just to turn your speech into text, but to accurately capture the user's true intent within complex contexts. Tencent's AI assistant, Unveils, has deeply participated in co-research and completed the initial integration, with related speech recognition capabilities now available to users for free. Meanwhile, the model has also been launched on Tencent Cloud's official website, providing API services and paving the way for enterprise-level application scenarios. Leading multilingual evaluations, dialect coverage a killer feature. On the core metric of speech recognition accuracy, high ASR 3.0 preview delivered an impressive report card. According to officially released data, the model's multilingual word error rate WER on open-source evaluation sets is controlled at a low range of around 3%. Specifically, the Mandarin Chinese WER is 3.34%, the English WER is 2.62%, and the Cantonese WER is 3.12%, with overall performance leading competitors. In comprehensive scenarios using self-built evaluation sets, whether for general recognition, dialect recognition, or contextual understanding, the WER of high ASR 3.0 preview remains at a similarly low level. Notably, dialect recognition capability has become a major highlight of this upgrade. High ASR 3.0 preview does not force users to use standard Mandarin. Its dialect recognition range covers 10 major dialect regions, including Cantonese and Wu Chinese, as well as over 20 secondary sub-regions. This means that even if users speak tongue twisters in their hometown dialect or mix Chinese and English, the model can handle it with ease. In long audio scenarios such as meeting minutes or interview transcriptions, this inclusivity for non-standard speech will greatly enhance transcription efficiency. 4 core capabilities reshape the interactive experience: understanding context, recognizing jargon, resisting noise. From the perspective of actual user experience, high ASR 3.0 preview focuses on reshaping 4 core capabilities. First is the significant improvement in general recognition accuracy. In scenarios involving general speech, dialects, and Chinese English code switching, the model effectively reduces character errors and omissions, and suppresses the accumulation of errors in long audio transcriptions. Second is its powerful contextual awareness, a key differentiator from traditional ASR. Traditional speech recognition often struggles with homophones, for instance, failing to distinguish between midterm exam and final exam, or carcinogenic substance and cancer-treating substance. Leveraging the language understanding capabilities of the Hi3 base model, Hi-ASR 3.0 Preview can accurately capture the user's context, intelligently correct homophones, and resolve semantic ambiguity, achieving an effect where the more you speak, the better it understands you. Third is rapid adaptation to professional scenarios. The model performs excellently with industry jargon, such as EBITDA in financial reports or proton nuclear magnetic resonance spectroscopy in chemical research. Furthermore, its supported hot word injection enhancement feature helps the model quickly recognize brand product names, personal names, and industry terminology. For enterprises, this significantly reduces the cost of business integration and subsequent maintenance. Fourth is high robustness in complex acoustic environments. Real-world scenarios are filled with various noises. Hi-ASR 3.0 Preview has been specifically optimized for high noise, whispering, and hushed speech scenarios. Whether in a noisy subway station, a KTV, or a coffee shop or library requiring low voices, the model maintains stable and accurate recognition performance. Unveiling the technical foundation, MO architecture and tens of millions of hours of data training. The leap in capabilities of Hi-ASR 3.0 Preview is rooted in a systematic reconstruction of model architecture, data scale, and post-training optimization. At the model architecture level, it adopts a mixture of experts MO architecture that balances efficiency and performance, and upgrades the base model to Hi3, thereby gaining stronger support in language understanding, contextual modeling, and semantic reasoning. On the speech side, the Hunyuan team developed an unsupervised speech encoder. Trained on tens of millions of hours of unsupervised speech data, it can extract high-quality acoustic representations from various complex audio sources. As the team puts it, the encoder is responsible for listening well, and Hi3 is responsible for understanding correctly. At the data scaling level, the team jointly trained the speech encoder and the large language model, introducing tens of millions of hours of multi-source speech data covering various dialects, accents, and acoustic environments, and performed fine-grained annotation through high-quality data pipelines. Through multi-stage capability injection, the model gradually acquired advanced abilities such as contextual awareness, complex scenario adaptation, and dialect recognition. Post-training optimization also played a crucial role. Focusing on general recognition, contextual understanding, and robustness in complex scenarios, the team built a high-quality supervised fine-tuning SFT scheme covering context, specialized terminology, different acoustic environments, and diverse speaker voices. On this basis, the team introduced multi-stage reinforcement learning, optimizing for general transcription accuracy, arbitrary contextual capabilities, and complex long-tail scenarios respectively, to reduce the model's misrecognition and omission issues in complex acoustic environments. Ecosystem rollout, Unveils first, Tencent Cloud API open. With the model's release, its deployment path is already very clear. Tencent's AI assistant Unveils has taken the lead in integration. Users can open Unveils, press and hold to speak, and immediately experience capabilities like dialect recognition, contextual intelligent error correction, and stable transcription in complex environments for free. Additionally, Products like WorkBuddy are also in the process of integration. In the enterprise market, High ASR 3.0 preview has been launched on Tencent Cloud's official website, offering external API services. It can be widely applied in scenarios such as intelligent customer service, content comprehension, and voice search. For various applications that need to turn spoken words into text, this undoubtedly provides a new option that combines high accuracy with strong semantic understanding capabilities.